Next, we have Celeste Freilich. Dr. Freilich is responsible for Intel Security Group's technical strategy related to analytics that integrate into the Intel Security corporate products. She brings 36 years of industry experience to the analytics CTO position, 21 of those with Intel. She has a PhD in biomedical engineering from Arizona State University, concentrating on predictive analytics and neuroscience. Welcome.
Good afternoon. Everybody hear me okay? Good. This wireless thing is like a cold stethoscope, so if I start squealing. I'd like to thank Wolfram for inviting me today. I appreciate it. And this talk will be probably a bit beneath you, but I'm hoping that you'll be able to take something away from it, particularly being able to tell the fake data scientists what we need to do differently. And there's a lot of them out there, and we'll address that. So I wanted to share with you why now, why you should care, the product lifecycle. I'll introduce the PLC as well as Agile, some select recommended content, and finally a summary. But why now? Well, of course, all of you know about Moore's Law and Gordon Moore there. And the number of transistors will double every 18 to 24 months. And of course, we're all connected. Right? And of course, the explosion of data. So everything I'm sure you're probably very aware of here, but what I thought was interesting was that I found being a biomedical engineer and not working in that particular field very much anymore, but I did find that a gram of DNA is actually, can theoretically hold about 455 exabytes, which I thought was phenomenal. So if you're in that particular area, I'd love to talk to you. There's some interesting research going on in there. But as you can see, the explosion of data connected, and certainly the power of Moore's Law is bringing us all together in this changing data. And of course, I spent quite a bit of time looking to see if we might have any more updated data than this wonderful report a number of years ago from McKinsey. And this indicated that there was a 60% gap relative to the supply of data scientists. And I thought, surely, brings me back to the airplane movie, doesn't it? Don't call me Shirley. So surely it's been improved by now, right? Surely. But I haven't been able to find anything. In fact, what I did find was a number of people said that there wasn't a problem anymore. And so I did a little more searching, and there was a gentleman from CEO of Newtonian, I don't know if he's here or not, but he said there is still a significant gap, and I'm going to go with that. So living in that world of data, as we do at my company, we find that there is quite a bit of issues with not enough data scientists to go around. I added this because, and I didn't circle biomedical engineer, I wish I would have, but there's mathematician, statistician, and data scientist. I'm also a trained statistician. Okay, and I'm a data scientist as well, but there's the best jobs in the United States, and it was a little scary to hear 36 years in the industry, and that doesn't count what I did while I was going through school. So that's kind of scary. I don't know if I'll live to see the result of the best jobs, but I love what I do, and certainly we've had an enjoyable time taking Moore's Law and taking the connectivity and the data and bringing them all together for incredible intelligence. But why are there so many fake data scientists? It drives me crazy, and it's one of the things I harp on quite a bit, particularly, and I apologize to all the computer scientists out there, but particularly computer scientists who have not been trained. I'm sorry, you can attack me later. Particularly who haven't been trained in statistics. So I did notice this particular, and I stole this from a site, and I should have used my own, because actually what I had instead of advanced analytics was statistics. And as I said, I am a trained statistician, but I do worry that data scientists and computer scientists aren't typically trained in statistics. And one of the things I found was that when I had a young lady come up to me and she said, I have a wonderful correlation in the product being moved in a retail space from this point to this point and that point to that point. I said, really, what did you do? She says, I used XYZ tool. And I said, that's great. I said, you found a correlation, that's great. What was your correlation coefficient? And she said, what? And I said, do you not know the distribution of your data in order to select your correlation coefficient? She goes, no, I didn't do that. I just plugged my numbers in. And I have to tell you, I find that constantly. And it drives me absolutely batty, and you don't want to see me go batty. But you know, Tom Davenport from Babson College, he indicated that in the HBR article that data scientist is a sexy title. There's a demand for immediate business intelligence and action, and of course, one I was given a couple years ago was give me an idea of how these HVACs on top of a theater are actually talking to one another with 300 different variables each, and I want it in a week. And I said, do you not understand 80% of the time is spent cleaning the data? And he said, I don't care, I need it now. The customer needs it now. So there's a lot of management pressure for immediate action without understanding the process. There are too many areas to learn. Certainly, we have data scientists that are experts in data management, software development, and maybe not all of them. There's too few data scientists, as we indicated, supply and demand, and it's an ill-defined job role. And there's an easy-to-learn mentality without underlying statistical fundamentals. I can't tell you how many millennials come to me as a technical leader of a very large company, and they come to me and they ask, I want to be a data scientist. What do I have to do? Can I take a class and I'll be done? It's more than that. It's more than that. So what can we do to help them? What can we do to make them feel a little bit more at home and a little bit more competent at what they do? So we put together the waterfall product lifecycle. I'm sure you're all very familiar with it, but what we did was as you're all familiar with the waterfall product lifecycle? Yes? No? Yes? Okay. So it's pretty common. There's all kinds of different life cycles, but what we did was we lined up the analytic process of define usage model and problem framing, an analytic risk assessment that you take throughout the entirety of the flow. We define the requirements, of course, trace back to the customer, a state-of-the-art assessment where you look at the literature. Many of my colleagues, particularly those that just fresh out of their bachelor's, they're often running calculating. And I ask them, have you even looked at the literature? It's probably already been done. And if it hasn't, then go off and do it, but maybe you can learn something. I actually had somebody talk to me about the growth of support vector machine, the clusters next to the support vector machines, the hyperplane. And he wanted to understand the growth. And you know where I found a wonderful, wonderful paper? Was on bacteria growth using SVM, totally out of the field. But when I brought it to him, he was able to understand it, and so he's got a little taste. So, you know, I think it helps. Analytic plan and peer review, I'll go over that. Verification and validation. Discover and develop and iterate your analytics is what we all do day in and day out. The report and peer review, as well as the post-production release analytic review, as well as the discontinuance. Now what I'm going to do is I'm going to go through a couple of these so I don't bore you silly. I did want to show you how it actually can integrate into Agile as well, for those of you who do Agile. And I'll review that just a little bit in this particular messy slide. So I did want to go over the fact that when you put an analytic plan together with a peer review, it actually helps quite a bit to let everyone know what you're doing in framing the problem. And if I've got it in red because how many managers out there go, we don't have time to do all this stuff, right? So with an epic, you can break it down into pieces in Agile. But you can also do the analytic plan and include everything before it. So you don't have to have, you just have to have a couple of reports here. State-of-the-art assessment we discussed, and as you can see, there's some purposes listed there, and y'all can read what we go through there. I did want to share with you, though, that we have a 77-page document that just absolutely terrifies our engineers, our data scientists. And I go, it's not that bad, really. There's only about I don't know, about 30 pages or so that really have the bulk of the material, and the rest is all appendices to really help you. And one thing in particular, each section has these purpose, entrance criteria, the audience, and so on. The formats and the templates are very helpful for the new data scientists, and so we have a lot of help there. The entrance and the exit criteria, what goes on before, what goes on when you leave it, the outcomes, what do you expect at this point, and where to store the information. Most people forget that we need to store the data. We need to indicate the data. And if you're working with a government entity, and I'm from the medical side, I can tell you, and the military side, I can tell you that they need that information. And working with a commercial company, I can tell you that we have legal records as to how long we're supposed to do things. So that's very important to us as well. The analytic plan and peer review, I want to go through just a little bit to give you an idea of things that you probably already know, so consider this just a refresh and pass it on to the younger data scientists coming up. So what does the customer want and why? We need to really understand what the usage model is, what the user experience is, and traceability starts here. And if I can do this, I'm not sure I can. This didn't work before. And I'm not a Mac user. So this actually speaks to framing the problem. Now, as you know, we have an edge or a client, down at the sensor level. We have the nodes and the gateways that can pass through, and we have the cloud and different types of clouds, right? But we really need to assess the environment and frame the problem before we get started on our data science. And the reason I say this is a company that won't be mentioned has a particular manufacturing site in Ireland. It's a very well-known company, and we were asked to go over there. And put in predictive analytics. We got over there, and they were literally still handwriting their entries. And when they took out their product out of their bath, they were sitting it down on the floor and opening the door for it to dry. Is anybody scared? Oh, come on, you should be. That's kind of scary. That's not the right way to manufacture a product.
But it took bars? Maybe it works out for bars.
It didn't. It was in Ireland. Sometimes it's, yeah, who knows? But it did. And then they were curious as why everything was a different thickness. Duh. Or why things didn't dry as well. But the point being is these guys wanted predictive analytics. Oh my gosh. You're not ready for predictive analytics. You are ready for just documenting product, right? So anyway, be aware of the current infrastructure, the desired infrastructure, certainly the data being collected, where they are in their maturity. And this is just a sample list of questions. We actually have about 100 of them. But be aware that there are limitations with their latency and as well as their bandwidth. see if I can do this again. I am not a Mac user. This is just so bizarre. Okay, so traceability. Start with traceability. Start tracing and listing every one of the user requirements here. And hopefully it'll work. Oop. No, it didn't. All right, so it didn't build, but the analytic risk assessment, continue it throughout the development. Understand your sources of error. One of the things that I find with the young engineers is they don't list the sources of error, nor do they put down a mitigation plan. It's something that you do on a routine basis as a statistician, always. The cost-benefit ratio, I have a current manager right now that would like to see how one person does their security, because I'm in Intel security. One of the things they want to look at is the URLs that they're going to, and then use that same type of analytic algorithm for the next person. So there's a cost-benefit ratio with that. How much do they want to spend doing that algorithm? How much space do they want to look at? Cache, memory, challenges. I like ISO 14971. Does anybody, there's an FDA person in here somewhere. Is there anybody that's familiar with this particular spec? Anybody? Oh, good, thank you. It's kind of bright out there. It is an awesome spec. I love 14971, I really do. Yeah, it's a pain in the butt, but man, you go through it once and you'll be an expert at it because it helps you understand what all the hazards of your product are. And it doesn't have to be medical. You can apply that to just about anything. Define requirements right up front. Sample size, acceptance criteria, output, the state-of-the-art assessment we talked about. Plan includes the intent, the hypothesis, the targeted p-value, and all of this other stuff that I won't go over, but at least you get the idea of the fact that start with the planning and please list it to begin with. And take the time to understand the problem. I'm actually working with somebody now that has worked on the problem for about a year, and I finally stopped and said, you know, because I just came into this particular group, and I said, can you please frame the problem and fill out this? And he was shocked at some of the information he did not know, and it changed the way he approached his problem. So, discover, develop, and iterate analytics. It's not building. There we go. Well, all right. So I built on I built on a PC and it's been transferred to a Mac. So I thank Apple for that. You're all familiar, I'm sure, with the Gartner foil. Be aware that we have reporting, reactive and proactive, and you have to do descriptive. This is like I was talking about in Ireland. We need to make sure we do descriptive before we do diagnostic, diagnostic before predictive, predictive before prescriptive. I like to look at reporting, reactive, and proactive within the descriptive and diagnostic. And of course, I'm sure you're all pretty familiar. Again, it's not building very well. Sorry, it's supposed to be a build here. But this is the general process of analytics. I'm sure we all have done that. The takeaway here is please do your basic statistics first. It's really, really important to understand the distribution of your data and to understand the relationship of the data. And finally, you can certainly get into system evaluation. And what I've done here is, even though it's not a linear process, it helps to explain to the new data scientists exactly what you should go through instead of just running right into a tool without doing your basics first. So again, this is all helping us to weed out those data scientists or the fake data scientists, or better yet, make them a good data scientist so we get good data. This is another one, if you didn't like that last one, this is the CRISP DM model that I'm sure you're all familiar with. But the one thing I learned from working in medical for so many years, and I'm hoping the FDA person or the medical person will appreciate this, is that we've taken validation and verification and we've brought it into the development of analytics. And an easy way to remember this is, have you done the right analytic is validation. Verification is, have you done the analytic right? So have you done the right analytic will trace back to your customer, and again, here comes those codes that you use to trace from user to requirement to result. And the verification really talks about, have you done your model right? Have you done the mathematics right? Many folks that I've dealt with have done SVMs and SVMs only. That's all they look at. And I said, have you looked at the ROC, have the receiver operating characteristic curve? Have you looked at the R-squared? Have you looked at the confidence limits? Have you looked at all of these other things? And they go, well, no, it just said it works. So I ask them to please look at some other things, other models. I will look at anywhere from 3 to 5 models on every project I use. And if you don't, please do. There's a legal issue of doing validation and verification. You need to document your validation and verification and produce all the graphs and all the data that you've done at this point. From a legal perspective, it really helps with mergers and acquisitions. If you do an acquisition of a company that has a fancy data solution, the first thing you should ask them for is this information. If they don't have it, you could actually be legally liable. If something, say a self-driving automobile or something like that, fails. So from a legal perspective, stealing validation and verification from the medical world is actually very, very smart. But where is all the software, you say? You know, surely you've got to be a software, don't call me Shirley. Surely you've got to be a software engineer, right? And you do data science. So you're one of those wonderful people that merge both of them. Well, you can do the analytic V&V, and then you can do the software validation, and then you can do the system evaluation. You get 3 validations. That'll just drive your manager crazy. And you won't get your product out real fast. But there's also, all right, I've decided from now 4 graphs that PC to Mac builds don't work. So it was supposed to be a build, sorry. So you could do concurrent, which we find to be the most common, analytic software and system validation at the same time, or an agile approach as reflected in a previous slide for software validation and analytic V&V, and be able to get your software done as well as your algorithm done as well. All right. The Analytic Report and peer review is to document the background, methods, results, conclusions. Those of you who have written a master's or a PhD or a paper, you'll recognize this. It really should be done in analytics as well. It's to mitigate the fact that you've got somebody leaving and they're right in the middle of doing some data cleansing and they leave for a better job over at Google, and the next thing you know, you're back to square one. You really need to capture that work that they've done. Include the how, why, where, when, what, and who, as we heard from Brian earlier. It's really important for the repeatability as well as in ensuring that when somebody does leave, you know where to pick up the pieces. Remember the revisions, not only of the tool that you're using, but the hardware that you're using, and also the implementation constraints that you had with the memory, the cache, and so on. And lastly, the post-production release analytic review. This is a broken down house here. You don't want that. You want to make sure that once you've done your algorithm, that it's out in the field, it's working really well. You want to look at it every so often and ask if it's still the same. The features and design space can change. Data decays, processes move, processes change. You minimize your liability, you protect your IP, and also the M&A. The data flow is very important. Make sure that when you do your data flow that you capture all of the information about the process and what's happening mathematically to that data at the edge, at the node, and at the cloud. Lastly, to sum up, the analytic discipline will protect you and your company, as well as your customer. And so there's legal issues, repeatability issues. You want to optimize your model. To do that, you need that discipline. Where did you start? Where did you end? You want to monitor post-implementation because life changes. You want to be able to help those wannabe data scientists to become better data scientists. Document your process, and that way you'll be able to meet your customer needs. Thank you.